Hello everyone. In this video we're going to explore and study what are the famous decision trees. A decision tree is a classification or a prediction model. In this tutorial we're going to focus in decision trees just for classification, which is the main use case for them. Besides being a classification or prediction model, decision trees are a baseline for many other classification models, such as random forest or boosted trees. So here we have a classification toy dataset. In general, all the columns, but the last one, describe or define some variable that describe a specific data case, okay? And the last column, usually it is used to represent the class column, or in other words, what we want to learn to predict. So in this example, we have people that have three variables to describe them. The first one means that if they are client or not of a given bank, and the income variable says if the person has a low or a high income, and the history variable tells if the person has a good or a bad history paying the bills. Okay, so at the end we want to say, or we want to learn to automatically tell if a given person is going to be approved for a credit or rejected. So this is an example of a decision tree. First, the internal nodes represent the variables that describe the data, in this case, client, history, and income. The edges represent the values that the variable node can take. So in general, in every node, what we do before deciding in what direction to go down the tree, we check the value of the variable. For example, in this case, history, and we say, okay, if the history is good, we go down through the left side of the tree, and if the history of this particular person is bad, we go down through the right side of the tree. Finally, we have the leaf nodes. The leaf nodes basically have the final prediction of the model. And of course, they take the same values like the column class. So how to classify a complete new data point? In general, we just need to travel the tree from the root to the resulting leaf. For example, if we have a person who is a client and has a good history and high income, what will be its classification? Okay, so the first question is this person a client or not? We know that it is a client from here, right? So we move down through the left side of the tree. Then, how is the history of this person? And we know that it's good, okay? So we go down through the left side of the tree. Finally, we don't have to ask anything else. We already know that this person is approved according to this tree. So this is an example where not necessarily every time all the variables are being used for the classification. So how to build the tree? And this is actually the most interesting part, right? Because if we had the tree already, the problem will be solved. So the idea is to learn an algorithm that automatically builds a classification decision tree from the training data. So let's go back to our data set. We first must pick the best variable. And that's something we're going to figure out later, how we assess the variables or how we can score the variables in order to decide which one is the best. For now, and to understand the general overview of the tree building algorithm, we are going to assume that we know how to pick the best variable. Okay, so let's assume that at the beginning the best variable is client. We set that variable as the root node, and we create edges according to the values that the client variable can take. and then we must continue. For example, to continue building the tree from the left side, we go over the dataset assuming that the variable client is already set to yes, and repeat the process. Same thing here. To continue the same construction from the right side, we go to the training set and we just work with the rows where client is no. So let's do that. Here we have the training set and we already identify the different rows according to the value that the variable client takes. So we split the rows according to those values, and then we separate it in two tables. So now we have the same tree, right? The ongoing tree that we are constructing. From the left side, we have the table, and notice that now in both tables, the variable client doesn't exist because we already know its values. So it's not providing us with any information. So let's continue the building process. We need to do exactly the same, but now with the corresponding table. So let's go through the left side. In the left side, we have that table, and let's assume that the best variable in this case is history. So we go and set, again, the variable history in that node. So now for the right side, let's assume here that the best variable is income, okay? So we go and set income in the right side. And again, we must continue the process. We have the current version of the building tree, and we have on each side different tables. So again, in the case of history, we will have to divide the table according to the values that history take. And in the case of income, in the right side, we had to divide the table according to the values that income might take. And we continue the process again. So far, this is the summary of the general recursion. We pick the best variable, we set that variable as the root node. Recall that root is a relative concept, right? Because at the very beginning is the real root of the full tree, but as soon as we start going down, the root is going to correspond to actually internal nodes. So it's like the root node of the current subtree. Then we divide the training set according to that variable, and for each of the edges that result from that variable, in other words, the possible values, we continue the tree construction recursively, as in the step 1. Now we just need to know what are the stopping criterions. And they are mainly two. The first stopping criterion is when we reach the point where all the rows have the same class. So for example, here we can see that in this particular table, assuming that we've been dividing it after several steps of the tree construction, we end up in a table where all the rows have the same values in the variable. In that case, we stop the construction and we just set a leaf node with the value of that class. For example, in this case will be a leaf node with a rejected value. The second stopping criterion is when we reach the point where all the rows in the current table are exactly the same in the variables without taking into account the class. For example, here we can see that these 3 rows are the same in the remaining variables without taking into account the class, right? So in this case, it means that we have to stop building. And what class we are going to put in the leaf? The most voted one. So in this case, we have 2 approved and 1 rejected. It means that we will put a leaf node with the approved class. The remarks so far, decision trees are trained in a supervised fashion. What it means that we need a training set. In other words, rows with the known class to train the tree. There are some variants or papers that appeared later showing some cases on training a tree with some rows with missing class, but it's out of the scope of this tutorial. And we keep in mind that we need to figure out how to choose the best variable. This is something pending we have from this tutorial, right? We're gonna see it in the next video. And so far, we are assuming that the variables are categorical. It means that they have discrete values. They are not continuous. When we are assuming this, in every step in the tree construction, when we go and split the tables according to the values of one specific variable, we are assuming that that variable is categorical. Because if it was continuous, we wouldn't be able to do that. A usual trick that is done to solve that issue when we have a continuous variable is just by discretizing it in a set of categorical values.